We are here with Professor George Pichurov from Technical University. Please tell us, Professor, how do you evaluate the thermal comfort of a person in the office room in your article?
Hello everybody. Thermal comfort of a person depends on the environment and on the clothing insulation of the person and also on the physical activity that this person has. Which means that in order to evaluate thermal comfort, you need to know what is the environment, and this includes the air temperature, the air velocity, the air humidity, and the radiant temperature. So you need these four variables to know, and you also need to know what is the clothing value of the person, that is the thermal insulation of the person clothes, and the physical activity of this person in order to estimate the heat production that this person has. So if you combine all these parameters, the environmental parameters and the personal parameters, you calculate an index of comfort, which is called predicted mean vote, or PMV. And this index predicts how a person will feel at that place. So this index ranges between -3 and +3, which are the extremes of cold to hot sensation. Yep. This is how PMV, how the thermal comfort is evaluated. In our paper, we simulate the environment, so we calculate numerically the environmental parameters: air temperature, air velocity, radiant temperature, and humidity. And after we calculate these parameters, we use a second procedure, a second numerical procedure that we have developed, that takes these four parameters, takes as input also the clothing insulation and the physical activity of the person, and calculates for each grid point of the computational grid, calculates this predicted mean vote index. So in this way it predicts the thermal sensation of a person in the whole room. This is how it is done. So you need two instruments, in fact. You need first a CFD solver to calculate the room airflow and the corresponding variables of the environment. And then you need a second procedure to iteratively calculate the PMV index from these parameters. And you put this PMV index again into the data file, so you can visualize the distribution of the comfort. You can spot the comfort zones in the room, and clearly as a figure everywhere in the room, so you can tell where to place people so that they feel most comfortably. Also, there is one more index after the PMV. This is the PPD index, which is percentage dissatisfied. This directly comes from the PMV and estimates what is the percent of people likely to feel unhappy by having this particular environment. So if the PMV index predicts an environment to be warm, let's say the PMV is equal to 1, which means slightly warm, then a certain percent of people will be dissatisfied with this sensation. But if the PMV index is warmer or hot, let's say 3 as a value, then more people will be dissatisfied with this. So by visualizing the PPD index, which we have done, you can see the percentage of unhappiness of the people in this room, depending on where they sit. So this is in a summary.
Okay, Professor, thank you very much. This was Professor George Pichurov from Technical University for our journal Contemporary Energy Solutions. Thank you.
Thank you very much.